There we go. All right. So, yeah, go ahead and pull up your problems. Let's see here. My internet's not behaving, of course. Alright, so that's up. Give me 1 second. There we go. Alright, there we go. And, oh, let's see. I'm still trying to get used to not using Zoom. 2, 2, 3. There we go. Okay. So, number 22 here. All right, so let's just kind of go through these. We'll discuss them, and you know, we'll take as much time as y'all need. If y'all need to go over a question, all right, just say something, all right. Is it possible for three forces to have a resultant of 0 even if they all have different magnitudes?
Yeah.
Yes, it is possible. How? Well, I mean, you did one, right? I mean, this right here, the whole question. Is it this one? No. Where was it? This guy, right? The whole question was about making those things cancel out, right? You had three forces, all had different magnitudes, they all had different directions. So the deal is they just have to have different directions. So a simple example would be if you had a setup like this. And again, this does not have to be just forces. It could be a velocity or it could be an acceleration. But if we did this, we had a 30 Newton force, we had a 40 Newton force, and we had a 50 Newton force at a 37-degree angle. Whoops. Yes, that's right. So you would notice, like if you did that, this would have a y component of 30 newtons that would cancel out the bottom one, an x component of 40 newtons that would cancel out the one to the side, and they would all add up to be 0. All right? Number 34, which of these three vectors could or would best represent 2, 4, and 8 newtons? All right? Anybody got a guess to throw at me?
A.
Should be A. Let's see. Basically the sizes are all the same. 25, which of these three diagrams does not correctly show the addition of two vectors on a vector diagram? C. You got to add them head to tail, not tail to tail, or what is that, head to head? All right. Sorry, I'm just grabbing the calculator a little fast. All right, so the hammer one. 45-degree angle is the force of the hammer striking the board greater in the x or y direction. It's a 45-degree angle. What do you know about things at a 45-degree angle? Should be the same. Explain the difference between two successive displacements of 0, 5 and 5, 0, and then a displacement of 5 to 5. What's the difference? The what? Displacements are the same. What's different about them? The distance. Well, I mean, I guess you could say the time, but that's not really the factor here we're looking at. The distance is different. Basically, in the first one, you're going up 5. You're displacing yourself 5 in the y direction. Then you're displacing yourself 5 in the x direction. Whereas in the second version, you're just going straight like that. Okay. Number 34, given F equals ma is a vector equation. Describe the relationship between the directions of force and acceleration. So if I apply a 40 Newton force to the right, what should my acceleration be? To the right. All right? So the acceleration should also be to the right. Basically what that's saying is that the force and the acceleration should always have the same direction attached. Okay, what is the net force that is the result of combining a 30 Newton force at a 45-degree angle and a 45 Newton force at a 37-degree angle? So how do you do, what is the first thing you have to do whenever you get one of these? you have to break it into components. So you would do 30 cosine 45, 30 sine 45 to get the x1 and y1 value, which would be 21.2 and 21.2. Why are they the same? 45-degree angle. And then you would do the same thing with 45. 45 cosine 37, 45 sine 37, and you would get 36 and 27. All right, did a little bit of rounding. What's the next thing you have to do? Add what? Add the x's and the y's together. So we get x total, y total should be, well, I can do this, 57.2 and 57.2 and 48.2. All right, then what? Pythagorean theorem, so 57.2 squared plus 48.2 squared, square rooted. Whoops. And, hey, gummit. All right, second square root, 5595. Should be 74.8. Is that what y'all got? So the resultant would be equal to 74.8 newtons. Is that all you have to do? You have to find the angle, right? So we got to do inverse tangent y value over x value. And you should get 40 degrees. And then pause for a second when you get done doing this and look and see if that makes sense. You had one angle at 45 degrees, one at 37 degrees. Would it make sense when you add them together to be halfway in between that? Should.
Oh, yes.
It should, right? If you're pulling, like, let's make it simpler. If you're pulling at an x and a y, right? If one person's pulling in the x direction and one person's pulling in the y direction, you would expect the object to move kind of in between those two, right?
Mm-hmm.
So the same thing is true here. And this one happened to work out where you could almost get it right by just doing 30 plus 45. But notice it's not quite the same, right? You can't just add those two together. All right, number 55, sorry. At what angle is a force directed if it's horizontal is 10 and its vertical is 15? What did you need to do there? Inverse tan 15 over 10. And again, you could do 10 over 15 as long as you were specific that it was coming off the y-axis and not off the x-axis. That's fine. What should the answer have been? 56 degrees. All right, what is the range of magnitudes that can be obtained with a 7 and a 5 Newton force? What's the range of magnitudes? 2 to 12. All right. Did I explain this right? Do y'all remember what my explanation was? Let's see. I don't know if I think I replaced my boards, but that's okay. Let's see. I'm trying to find something that'll work. All right. So if this box is the 5 Newton and this is the 7 Newton, right? If we put them, like, let's say that this is we put them head to head, you get 12. You put them head to tail, you get 2, right? This little bit right here. And then anything in between, right, would have to be somewhere in between 2 and 12, right? Because if you start making this an angle, if I bring this up a little bit, it's going to be slightly less than 12. If I bring this up a little bit, it's going to be slightly more than 2, right? So you're going to be making anything in between there. And you can't make anything else. All right. What is the horizontal component of a force with a magnitude of 100 newtons directed 60 degrees? All you had to do on this one was what? 100 cosine 60, and the answer to that was 50 what? Just 50, right? It's a 0.5, okay. All right, so find the components of the resultant of the following forces. All right, I did too much on this one, so if I told you wrong, I apologize. All you had to do here was add them up. So 15 plus a negative 8 would give you 7 in the y direction, positive 7 in the y direction. 4 newtons to the left, 20 newtons to the right would give you 16 in the x direction. And you could just call it a day there, all right? That's what they're asking for. If you went ahead and did the rest of it, I'm not holding that against you because that's what I did too, because like once I get in the rhythm, that's kind of where my brain goes, so. All right, determine the force required to make the net force 0 in the equation above. So what do you have to do here? Yeah, and what should the x and y components of this force be? What should the x component be?
40.
Should be 40. You're canceling out this force here. Okay, what should the y component be?
20.
20. You're canceling out this one here, right? So this would be 20, and this would be 40. And if you did that, what would you get?
44.7.
Sounds reasonable to me. 44.7. And then we do need to know the angle still. So what was the angle on it? 26 degrees. All right. Let's see. Okay, then number 64, we're doing the same thing, except what do you have to do first? You have to break this into components. So, 30, you got to break 30 into components, 30 cosine 45, 21.2. So we've got basically x1, y1 is 21.2, 21.2. And both of those are positive because they're up and to the right. And then we got to break the 50 into its components, right? So 50 cosine 25, 50 sine 25 is 20, sorry, go away. So x2 is 45.3 and y2 is 21.1. All right? But what do we know about this 21.1? What should it be? Why would it be negative? 21.1. Should be negative because it's going down. All right? So I'm going to, all right. Now, this isn't perfect, but we're trying to figure out what F needs to be, right? So what needs to be true of F? What does it have to do?
Equals 0.
It has to, sorry, say it again.
Equals 0.
It doesn't have to equal 0, but it has to make the system equal 0, right? So the x components of the force need to do what to the other two? It needs to cancel them out. So if I do x1 plus x2, that would be 76.5. And if I do y1 plus y2, I'm just going to round it and say it's 0, right? Because 21.2 minus 21.1, we're going to assume they meant that to be 0. Technically, it's 0.1, but we'll fudge it. All right? Which means that the force needs to be what? What does this force need to be? Negative 76.5. All right? And you could, I mean, theoretically, you could put that 0.1 in there, but the degree is going to be like 0.05 degrees or something like that. It's kind of ridiculous. The key thing on these is to cancel out the forces. You have to make sure to, like, first of all, I noticed this is giving you all a lot of trouble. You were trying to just do 30 minus 50 or something like that. Anytime something's at an angle, the very first thing you have to do is break it into components before you can do anything else.
So wait, what was the x component, the x2?
Sorry, hang on a second. What about it?
What was x2 equal to?
45.3.
Whenever I add together, I get 66.5.
Oh, because I'm dumb and can't do math in my head. 66.5?
Yes.
All right, my bad. Yep. That makes sense. Sorry about that. All right. How far have you walked from your starting position if you walk 12 meters north, 18 meters east, and then 9 meters west? I know that it seems ridiculous sometimes, but it does help to draw pictures, all right? So what we're going to do, we're going to go 12 meters this way, and then we're going to go 18 meters this way, and then we're going to come back 9 meters this way, right? So how far are we from where we started is the straight line distance. It's not how far we walked. How far did we walk? What is it? 12 plus 18 plus 9. We walked 39 meters, right? But we were only displaced this amount. Okay? And again, just like we did with everything else, I've told you it doesn't have to be a force. Here it's a distance, or sorry, a displacement. So you just add the x's, add the y's, and then do the Pythagorean theorem. Okay? So in this case, it would be x would be equal to 9 meters, and y would be equal to 12 meters. You just do the Pythagorean theorem on it. And it just says how far. It doesn't say what the angle is, so I think you can just leave it. So what was the distance you travel, or displacement you travel? What was it? 15 meters? Ah, good, a 3, 4, 5. How convenient. Okay. All right, let's see, I believe these were next. Okay, so what is the magnitude of magnitude of your acceleration if your velocity changes from 10 to 13 meters per second and your vertical velocity changes from 2 to 6 meters per second in 4 seconds? Again, you can have vectors that are not just forces or distances or velocities. In this case, it's an acceleration, right? So you have to find the acceleration in the x, the acceleration in the y, and then put them back together. So the acceleration in the x would be 3 over 4, and the acceleration in the y would be 4 over 4. All right, just finding, like you're just using that acceleration formula, a equals v minus v naught over t, right? Or change in velocity over time if you want. What would I do at this point? Pythagorean theorem. You should notice a trend, right? Okay, so what's 1 squared plus 0.75 squared? What is it? 1.25. So it'd be 1.25 meters per second squared, and then you got to find the angle. What was the angle? Y'all didn't find the angle. Oh, it does say the magnitude. Since it says the magnitude, you don't have to find the direction. So if you just see the word magnitude there, it doesn't say magnitude and direction, you can stop there. All right. A boat is traveling at 4 meters per second north relative to the water that is flowing at 2 meters per second. A, what is the boat's velocity relative to the land? Okay, so what does that mean? What is it asking? If you're looking at this boat from above, what's the boat going to be doing? It's going to be kind of cruising off in this direction, right? So the boat's velocity relative to land, guess what we have to do? Pythagorean theorem. So 4 squared plus 2 squared is 20, and the square root of 20 is something in between 4 and 5. So 4.6 meters per second. Pythagorean theorem of 4 squared plus 2 squared. Okay? Am I done? Got to find the angle, all right? So then you got to do second tangent, 4 divided by 2. It's going to be cruising at 4.6 meters per second at 63.4 degrees. Okay, so next up, how far downstream does the boat go in 10 seconds? Which velocity am I concerned with?
2 meters is 2 meters.
You're just going to be concerned with the 2 meters per second. It's not asking how far the boat went. If it asked how far the boat went, you would be saying 4.6 meters, like you'd do 4.6 meters per second. If it's asking how far across the river did it get, you would use the 4 meters per second. But if it's asking how far downstream, you just use the 2 meters per second. Okay? So how far downstream would it get?
20.
Should go 20 meters downstream. And finally, how long does it take the boat to move 100 meters across the river? So we're just assuming it goes straight across the river, trying to move straight across the river 100 meters. I don't know what this means. Sorry, this isn't in the problem. I don't know why she added that. Okay, how long would it take the boat to go 100 meters across the river? Which velocity is getting the boat across the river? it should be the 4, right? So if it's going 100 meters across, how long would it take? Should just take 25 seconds. All right? So again, whenever you're working with vectors, be conscious of like which one you need to be using. All right? How long does it take a car traveling 18 meters per second at a 40-degree angle west of north to go 900 meters west? Okay. So again, we got a car going west of north this way at 18 meters per second, and it's got a 40-degree angle here. Sometimes they're really annoying about this, so you have to be careful with it. If it's west of north, you start at north and then you go west of it. If it's north of west, you start at west and you go north of it. Y'all, you see what I'm saying? It's a little bit, sometimes it's confusing. All right, if you go, so like if it's north of east, you start at east and then you go north of it, however many degrees. Okay. So if we want to know how far it went 900 meters, how long it took to go 900 meters west, I need which velocity? Am I going to use 18? You got to do what? Got to break it into components. You really just need which component? Just need the x component. So I'm going to do 18. In this case, it's to be 18 what? It needs, if I need this vector, right, which one would I use? I'm going to use sine in this case, 18 sine 40. So I'm going 900 meters at 11.5 meters per second. It's going to take me 78 seconds to get there.
Could you do 18 cosine of 50?
You could. Should give you the same thing. Okay, what are the components of a 20 meter per second velocity that is directed 10 degrees above the horizontal? All you have to do on that one is just do like 20 cosine 10, 20 sine 10.
It doesn't necessarily ask for the magnitude of the components.
Yeah, but if it's asking for components, that's what they're asking for. I mean, they've already given you the angle, and so all they're asking you to do is to break it up into the two components. Yeah, I mean, you're right, it doesn't ask for the direction, but if it's asking for components, it's asking for x and y. So you would just do 20 cosine 10, 20 sine 10, and that would be 19.7 and 3.5. That'd be the x component. Real quick, I didn't tell you all this because I don't know if it comes up. I don't know if Desmos does this. Does Desmos default to degrees?
No.
Okay. Well, just FYI, if you're doing vectors, make sure it's in degrees. Did anybody get messed up by that? I'm sorry, I forgot to mention that. I was hoping that y'all would catch it. All right. Last three. Okay, so birds flying 20 meters per second at 60 degrees. Calculate the bird's velocity vector in component form. So component form, what do? Just break it up. So it should be 20 cosine 60, 20 sine 60. So x is going to be 10 meters per second. Y is going to be 17.3. How long does it take the bird to fly 100 kilometers north? So what's the first thing I'd have to do there?
Use the y.
I do have to use the y, but it's in kilometers, so I need to get it into, so it'd be 100,000 meters. And then, Caden, which one am I going to use, x or y? You're going to use the y. Okay, so you're just doing v equals d over t here. 100,000 divided by 17.3. It's going to take him 5,780 seconds to get there. And then how far east has the bird gone in this time? What would I need? Which one would I need to use? I have to use the x. Luckily, that's just 10, so the bird would go 57,800 meters